They can be really, really dangerous, so I don't want you to spill this, okay?
Yeah, some acids can actually absorb.
They can. This particular acid, if you spill this acid, you're going to end up smelling like a pickle.
I like pickles.
You like pickles? Good. So we're using vinegar here. Vinegar has a mild acid in it called acetic acid. The base that we're using, I'm sure you know this stuff, right?
It's baking soda.
Baking soda is a base. Does your mom or dad like to bake?
Well, my mom, she's not that good at it, but my dad's totally a champion.
Okay, so why do we use baking soda to bake with? You have any idea?
I think soda.
Okay. Actually, the recipe says to use baking soda. That's what we use. It gives off a gas in our cookie and muffin mixture, makes it nice and fluffy. So anyways, I've got some baking soda in this balloon. We're going to put it over top of the bottle. But I want to go back to my introduction about chemical reactions. During this reaction, this is going to either absorb energy or give off energy. What that means is that bottle is either going to get hot or it's going to get cold. Do you have any idea what it might do?
I think it's cold.
Do you think it's going to get cold? Okay, do you guys agree it's going to get cold? No, you do. Does anybody think it's going to get hot? It's going to get hot. Okay. So let's give this a try. We're going to pour the baking soda into the vinegar.
Wonder what it's getting.
And tell us, is that getting hotter or colder?
To me, it's getting a little more chill.
More chilled. That means colder, right? Okay. So most of you guys out there were wrong. This guy got it right. You got it right, too. We're filling the balloon up with what state of matter? Have you learned the 3 states of matter?
Oh yeah, solid, liquid, and gas.
Which one is this?
Gas.
Awesome. So the particular gas that we create here is carbon dioxide. Have you heard of carbon dioxide?
Yeah.
Okay, good.
When you breathe it out, when you breathe air out, it turns into carbon dioxide.
Exactly. We take in air and oxygen and we breathe out
Carbon
a
dioxide.
little bit of carbon dioxide. So, okay, so what I have here in this container
It's in water and a little bit of sugar, I think.
actually is hydrogen peroxide and yeast. So you were close. And doing that, we actually create oxygen. You've heard of oxygen. Feel this container.
It's a little warm.
It is. So this particular chemical reaction,
It's almost as
it's not
hot
that
as
hot.
my dad.
It's not that hot.
Well, I'm not that used to people like touch something a little colder.
Okay, so anyways, this one is giving oxygen in the process. Actually, again, we're using hydrogen peroxide to make oxygen. Do you know this stuff by any chance? You use it at home?
What? Wait, no.
Oh, okay. Anybody use this at home? You use it at home? You put on cuts? When you put on your cut, what happens? It foams up, right? Makes little bubbles. Those are bubbles that clean out your wound, and also pure oxygen kills certain germs and bacteria. Cool stuff. The kind that you buy in the drugstore, the kind that we have here, is only 3% hydrogen peroxide. The rest of it's water, so it's really diluted down. So there's like that much pure hydrogen peroxide mixed with an awful lot of water here. If we had a container of pure hydrogen peroxide like this, we probably wouldn't, but if we did and dropped it, it actually might explode. It's a very dangerous chemical. Pure hydrogen peroxide is often used for rocket fuel. So we're using diluted rocket fuel on our cuts to kill germs. Anyways, young man, I'm going to be doing a demonstration with fire, and I don't want to singe your hair, so I'm going to have you sit down now, okay? Let's give this guy a hand for being such good helper. Good job, buddy.
I can take these off. I don't want to steal something.
Okay.